All right, on page 97. Max, will you do me a favor and go back there and turn on that little light? I meant to when I walk by. Yeah, might as well turn it on anyway. Again, I would highly suggest writing down a few of these in your notes to make sure that you understand them. Number 14. I know this is sort of boring sometimes to just run through these, but make sure you follow along so you understand what's going on. State the property that justifies each statement. Measure of angle A equals the measure of angle B. Use your notes there too to help me so we can write down the properties. The measure of angle B equals the measure of angle C. Then, what do you know? Measure of angle A equals the measure of angle C. What property is that? Look back at your notes there. What property are we using there? Transitive property. Very good. Transitive property. Whenever you make a statement, we made this statement, we got to give a reason. That's why these two column proofs are going to work. All right? Number 15. Got something to write with? You don't want to write none of this down? Maybe? Are you giving up on me? Number 15, HJ, segment HJ plus 5 equals 20. Then HJ equals 15. What did you do in that problem? How'd you go from this to that? Wade, what'd you do in that problem? I'm gonna start calling on people. That's gonna wonder.
I didn't do it. I wasn't.
That's all right. Just look up here. What'd you do to go from here to there? Make a guess. Addition property. So what, explain to me, what did you add? Addition property of equality, is that what you meant? What did you add to both sides? Did you add 5 to both sides to get that? What did you do? Now, is it just subtraction? Can I just write subtraction? No, what do I gotta write? Subtraction, property, and I don't mind if you abbreviate a lot of this stuff. How come I didn't abbreviate subtraction? Sort of did. I left off a few letters. Because substitution would look the same, so I gotta know the difference. Subtraction property of equality. Use the subtraction property of equality because all you did was subtracted 5 on both sides to end up with what you had. David, is that what you were gonna say? Next one, XY plus 20 equals YW. XY plus 20 equals DT. Before I write down anything else that they've got written, what do you notice here? Those are the same, aren't they? Well, if xy plus 20 equals yw, xy plus 20 equals dt, you guys having trouble?
Oh, it was on under there.
So, what do we know about these two parts? They're equal, so probably what they have written down there is yw equals dt, right? And how, I probably had then in front of it. How can we make that conclusion? What property allows us to make that conclusion? It's close to transitive. It's the bad thing here is, and I'd probably accept transitive. The bad thing here is, to be transitive, it has to go in the correct order, and it doesn't. So what did we do? We took out this, and what did we put in its place? dt. Well, what did we use there then? Substitution property. Substitution property. (17) Angle 1 plus angle 2 equals 90. And angle, the measure of angle 2, sorry, I should have put measure on each of those. Measure of angle 2 equals the measure of angle 3. If that's the case, if angle 2 equals angle 3, what could we do right here with angle 2? Take it out and stick what in there? Angle 3. And what did we use there? Substitution again. I didn't write the then statement. The then statement would have been, the conclusion that we could draw is measure of angle 1 plus measure of angle 3 has to equal 90. What's another statement you could make after that? What do you know about angle 1 and angle 3 then? What kind of angles are they to each other? Starts with the C. Not congruent. Two angles add up to 90. What kind of angles are they? Complementary. Alright, so that's sort of, and this is a theorem that we're going to cover later on the year. It's going to say, if angle 1 and angle 2 are complementary, angle 2 and angle 3 are the same or equal to each other, then 1 and 3 have to be complementary.
Pardon me, teacher, for the interruption. Mr. Curry, call the office, please. Mr. Curry, call the office, please.
Which one did we just leave off on? 17, now we're on 18. 18. This one's a tough one, so watch, make sure you understand. Got 1/2 times AB equals 1/2 times EF. Pen quits working in that spot. Then our conclusion that we can draw, AB equals EF. The length of segment AB has to equal the length of segment EF. Subtraction? Subtraction property of equality? Is that what you did? What would you do if I had this? 1/2 x equals 6. How do you get rid of that 1/2? Divide both sides by a 1/2. Now, is that normally what we do? Do we divide by fractions? No, usually if you have something like this, I probably would accept that. So if you wrote division property here, division property of equality, I'd probably accept that. But here, actually, probably what we're going to do is multiply by the reciprocal or multiply both sides by 2, and those just cancel out, right? So what property did we probably use here? Multiplication property of equality. Multiplication property of equality. 19, segment AB equals segment AB. What property is that? Reflexive property. Anything equals itself. Anything equals itself. Reflexive property. Later on in the year, when we get to other stuff, you're going to enjoy reflexive property because that's one of the easy ones. When we're doing a 2-column proof, and one of your reasons down here, one of your statements down here has to be AB, segment AB equals segment AB. You're going to put, that's going to be one of the easy ones, you're going to put reflexive property over here. Now remember, it's reflexive property, not reflective. All right, you're not reflecting anything, it's reflexive. What's the next problem? What was after 19? 20? 20 if how'd they get from this to that? What did they do? As soon as you see parentheses, you probably all think of what property? Distributed property. And again, you can abbreviate quite a few of these. 21 next. Which property allows you to state measure of angle 4 equals measure of angle 5? That's what we're trying to, that's our conclusion. And what we're given is measure of angle 4 equals 35, and the measure of angle 5 equals 35. This isn't a property, actually. How do you know that if angle 4 is 35 degrees and angle 5 is 35 degrees, how do you know angle 4 and angle 5 are equal to each other? They have the same measure. And what I'm going to write here is definition. Oops. Keep that big stupid thing. Definition of congruent angles. If two angles are congruent, then we know what's true about them. They have the same measures. They have the same measurements. Do what? What? What's next? I know, that's why I said it's not really a property. I don't know why they put property in there. Number 22, which property can be used to justify the statement that segment AB equals segment CD? We already did one like 22. What'd they do to both sides of that equation or that equal sign? Multiplied by 2, right? So multiplication property of equality. 23 next. Which property could be used to support the statement EF equals segment segment KJ, given that EF equals GH and GH equals JK? What property are they using there? We had one of these earlier also. If this equals that equals something else, transitive property. Transitive property. Which problem was next? 24? Right. make sure you're writing this one down in your notes. Those I didn't care a whole lot about. These, the 2-column proofs, I want you to have a couple of these examples down there in your notes. So write down, it says given, that's the information that we know. Can't write it up here, so I'm gonna skip a little space there. 3x plus 5 over 2 equals 7. This is the way these 2-column proofs are gonna look all year long. You have a given statement. This shouldn't be there, that's stray marks. You have given information, then you have what you're trying to prove. X equals, and I'm sure they give us an answer, but we'll figure out what X is. So we're trying to figure out what X is. As you're doing a 2-column proof, I think you guys said you called these what? T-charts. This column is always going to be labeled statements. This column is always going to be labeled reasons. Getting any this way? Every time you make a statement, you have to have a reason for it. All right? Can't make a statement unless you can back it up with a reason. The book letters theirs. I don't know, did they letter these? Yeah. They do A, B, C, D. I always use numbers. So for statement 1, what do I have to have?
3 plus 5 over 2.
All right, that's true. But what I was looking for was, you have to have a reason, right? So everything's got to match up all the way down through here. And Max is right. First thing we're going to put in here in statement 1, 3x plus 5 divided by 2 equals 7. Yeah, I know. We'll figure that out as we solve it out, won't we? So we know that. How did you know that 3x plus 5 divided by 2 equaled 7? How did we know that? Because it was, and that's what we write over here as our reason. That's one of the easy ones. Should everybody be able to get that, those first 2 parts right? Yeah. All right, so you have a statement. It's right here. Your reason is given. What's the first thing you start to do to start to solve this? How do you get rid of that 2 in the denominator? Multiply both sides by 2. When I multiply this left side over here by 2, what's going to be left over? 3x plus 5. 7 times 2, 14. What was our reason for that? How did we go from step 1 or statement 1 to statement 2? Multiplication, property of equality. So what you're doing as you're doing these 2-column proofs, what you're doing is explaining to the next person that looks at it, this is how you do this problem. You do this, and the reason we can do that is because of this property. You do this, and the reason is because of this property or this rule. What do we do after that? Subtract 5 on both sides. What's that leave us with? 3x equals 9. What property or rule did we use there? Subtraction. Subtraction property of equality. Subtraction property of equality. What do you do next?
Divide by 3.
Divide both sides by 3. What's that leave us with? X equals 3. How did we know that we could go from this number 3 down to number 4? What property told us that? Division property of equality. Are we finished? Did we get to what we're trying to prove? Yeah. Some things I'm going to say while you're finishing copying this down. This last reason right here, never, ever, ever should it be given. You can't have your last reason as given. Never should it be something like prove. All right? That last reason, if you write that in there, number one, it makes me very upset because I want you to have enough common sense to know if we get all the way down here and we did all this work and you put given as that last thing for what we were trying to get to, was there any sense in doing all that work? If it was given to you, if I told you that there was 6 elephants, then do you have to prove that there's 6 elephants? No. So this last reason right here should never ever be given, prove, anything along those lines. It's got to be some kind of property theorem, something with some substance to it. What's the next problem? 25? Problem 25. David, you still with us? What ones did we do after that? 28. Let's do problem 26, then we're going to go on. So write this one down. This one they didn't give us any of the. Why are they not putting? Yeah, okay. 26. Write this one down in your notes. This is, again, an important one. They say if, that's the given information. The if part is the given information. So we are given that 4 minus 1/2 A equals 7/2 minus A. That makes a lot of you real happy, right? Got those fractions in there. What are we trying to prove? Trying to prove what? A equals -1. So the if part, you with me? David, you with me? Set up. You're not with me. Come on now. The if part is the given information. The then part is what you're trying to prove. And it says A equals -1 this time. Statements, and I don't mind if you abbreviate the statements, reasons. You can abbreviate it however you want. You could just put S and R. I gotta separate you two, don't I? I know. It's starting to be very annoying. What am I going to put for the first statement? Write this down. I might just collect this here in a minute, make it a quiz grade.
No.
Yep.
Put it on my notes.
I'll give it right back to you. Be easy for me to grade because I can tell who's writing it down, who's not, and just give those people not bothering to write it down a 0. I'm not up here doing this for my health. How did we know that this statement was true? It was given. You guys will figure out here in a couple months when we get to these harder two-column proofs and all of your whining and crying. Man, I wish I did all that stuff back when Mr. Eversole told us so I'd have a better understanding of these. What's the first thing you're going to do on this to start to solve this? You could. Thing I want to do first to try to make it easier for you guys, do we really want all those fractions in there? So you multiply the whole thing by 2. What's 2 times 4? 2 times this negative 1/2, what happens with the 2's? They cancel out and you're left with just negative 1a. 2 times 7/2, just leaves you with 7, right? 2 times negative a, what did I use there? Multiplication property. Multiplication property of equality. Just multiply it both sides by 2. Now, is it an easier problem to look at? What do I do now? Next step, get all the variables on one side, right? So how do I do that? Add 1a, probably better if you do it the other way. Add 2a, because you usually take the smaller variable to the bigger one, right? In this case, a negative 2 is smaller than negative 1. If you add 2a to both sides, what do you end up with? Tell me what to write. 8. Is it going to be, if you add 2a to both sides, it's going to be a positive 1a. Then what? Equals 7. What allowed us to do that? Addition, property of equality. Now what? Minus 8 on both sides, right? What's that leave us with? 1a equals negative 1. What property allowed us to do that? Subtraction property. Of equality. Are we done? Is that what we were trying to prove? So do we have to go any farther? That's it. Now, when we do what we're going to cover here in a couple minutes, with segments and then next time angles and stuff, it's going to be a little more difficult because this stuff over here on the statement side, you should already know all that, right? Because that's what you've done last year and the year before that, probably. So you've already solved those. And all that's new is the reasons, given a reason for everyone. Well, now, as we do the angles and segments and other stuff, all the ideas are going to be new to you. So that's what makes these two-column proofs a little more difficult. Says I pick the groups, I'm going to let you pick. So you can work in partners, you can do whatever. There's 2 problems, 9 and 10. Shouldn't take you but about 5 minutes to do them. I think both of them, let's see, on page 97. 9 and 10, they're both 2-column proofs. Number 10, it says prove that, and they give you a statement there, then y equals negative 2 or negative 2 equals y. So just remember the if part is your given information, the then is your proof statement. Help each other out, write the 2-column proofs, they shouldn't take you real long. Get finished with them, you can bring them up, lay them on the blue chair up here,